Hi everyone, in this video we're going to be going over question 13 of the Spring 2021 Data 100 final. For part A, Alice is training a model and finds that as she adds more features, her training error is decreasing along with her validation error. What should she do? So if both training error and validation error are decreasing, this means that our model is performing pretty well. We're not overfitting because our validation error isn't increasing while training error is decreasing, so we can just keep our model as is. So no additional regularization or changes are needed. For part P, Alice is training a model and her training error is rapidly decreasing, but her validation error is increasing. What should she do? So when your training error decreases and your validation error increases, this means that you're probably overfitting, which means that your model is too complex. So in order to reduce the complexity of our model to prevent overfitting, we would want to increase regularization. Because when we increase regularization, we penalize the data parameter values in our model for being too large, which forces them to become smaller, decreasing our model complexity. So the answer to part B is option A. Then for part C, suppose you're interested in finding the minimal set of explanatory features, which form of regularization would be most appropriate. So recall that with L1 regularization, which is lasso regularization, it tends to set a lot of theta coefficients to 0. So if you ever want to just figure out which features are most important for a model and you just want a small subset, you want to choose L1 because a lot of the data values will be set to 0, which means that you're not using those features at all. But for L2, it's more diverse in that more of your data values will be non-zero. It gives more weight to your different features equally rather than L1, which just sets a lot of those data to 0, which causes those features to not be used. So in this case for part C, because we want to find the minimal set of explanatory features, which means we only want to select a very small subset of features, we want to use L1 regularization because then it will set a lot of the data of our features to 0. So all of the non-zero data values, which we'll choose all the features that correspond to non-zero data values, which would be a small subset. Then for part D, suppose Alice finds that her model is overfitting and she decides to add L2 regularization with regularization coefficient lambda to her model. As she increases the regularization coefficient lambda, which of the following are true? Okay, so recall that when we add regularization to our normal loss function, it looks something like this. So when we increase lambda, our regularization term becomes really, really big. And if it becomes really big, our objective function is going to penalize it. Because remember, for our objective function, we want our error to be as small as possible. So in order to combat this really large lambda, it's going to end up decreasing all of these thetas, or the values of the thetas, until the values of the thetas are constricted to some range around the origin. So as lambda gets larger, we penalize theta more and more, and theta values have to shrink. When theta values shrink, this means that they're getting farther and farther away from our optimal theta values. So this means that our model bias is going to increase because our theta values are no longer our optimal theta values and they're getting farther and farther away. But our variance for our model is actually going to decrease because as we penalize theta more and more, the theta values decrease. This means that our model is becoming less complex. And when our model is less complex, the variance also decreases. Moving on to part E, consider a simple setting in which we are predicting the height of a person in centimeters based on their weight. Suppose we include the weight measured in kilograms and milligrams as two separate features, and we tune the coefficient of the L1 regularization to include only one feature. Without normalizing the data before training, which feature would be selected after the model is trained? Okay, so we have two features, which are both measure weight. Just one is measured in kilograms, and the other is measured in milligrams. So on a unit scale, milligrams is much smaller than kilograms, which means that if we wanted to measure the same weight, for example, something like 150 pounds, the value corresponding to the kilograms will be a lot smaller than the value corresponding to milligrams, because we need a lot more milligrams to be able to match 150 pounds than we need for kilograms. So we know that the value in our milligrams column is going to be much larger than the values in the kilograms column. And this means that in order, if we have like our model, for example, theta 1 times x1 plus theta 2 x2, where x1 is the kilogram feature and x2 is the milligram feature, we know that because milligram is on such a larger scale than kilograms, at least for the specific value in the milligram columns compared to the kilograms column. This means that theta 1 is going to have to be a really large value in order for the kilograms to make any impact or prediction at all. So theta 1 is going to be a lot greater than theta 2. But because we're using regularization, and we know that regularization penalizes large values of theta. So when it sees that really large value of theta 1, it's going to penalize it very, very heavily. So because of that, theta 1 is going to, the really large value of theta 1 will be penalized a lot, which means that it's going to be set basically almost to 0, especially because we're using L1 regularization, which sets a lot of theta parameters to 0. So we'll just be left with choosing theta 2, which corresponds to the milligram feature. So we would be selecting the weight in milligrams. Okay, and this concludes the walkthrough for question 13.